So is it clear? The role of validation set has many roles. Can be for, firstly, we evaluate our model performance. Can be for model selection. Let's say you have trained many models and you would like to shortlist your models. So you use validation set to shortlist your model. You can use it for hyper tuning, okay? And so on and so forth. So anything related to your assessment to give you an idea about your model, you use the validation set. Once done, then you take the full training data set again. There's no validation set anymore. You have the final training for your model, the final time training, and then you proceed to use the final evaluation using the test set. After that, there's nothing. You shouldn't go back. Let's say you're not happy about the results of test set. Then better don't do anything. You should resist doing any changes. Because after all, remember, the model you are building is not to satisfy the performance on this data set. No, this is just historical data. You are using it to prepare your model for future. So there's no point of overfitting the test set. There's no point, because eventually you're not going to use the test set when you deploy your system into the user. You're not going to pass him the test set, tell him, oh, please, sorry, I'll just use this test set. Don't use anything else, right? That's not logical. Okay, so now we understood the role of validation set. However, having single validation set is also not enough. Okay, having single, just a moment, please. Just excuse me, 1 second. Okay, so having single validation set is not proper. Why? Because having single validation set means I can do assessment for one time, right? So imagine if student attending this course, and then eventually he has only one continuous assessment. Is that good? From the perspective of the student, he might be happy thinking, well, I don't need to do many things, just one time assessment enough. But actually, if you think deeper, it's not good for you. Because in case, for any reason, bad of luck, you didn't perform well during, let's say, first assessment, then you still have chance for second assessment, third assessment, right? So you can show the performance that you are good, for example, maybe just due to bad of luck, let's say the quiz, you didn't perform well, but you still have midterm, you still have assignment, you still have practical test. So the point is, I'm trying to tell you, having multiple assessments are better than having single assessment, because that can reflect the actual performance of the model. How? By taking the mean. So instead of looking into per se assessment, I can calculate the mean, and standard deviation can give me a better idea about how the model is doing. Meaning, if I see the model in all assessments are doing good, right? So that gives me more stronger confidence that my model is ready, right? Rather than if you run one time, you see bad or you see good, then you release your model, you are surprised that the model is not good, okay? So we need to have multiple validation set, the idea is. However, creating multiple validation set is not a proper way. So if we, for example, come into this just for the sake of argument, so again, this is our data set, then we have the full training data set here, we have the test set like what we have done earlier, and we have device to have our validation set. So now how many validation sets we have? One. Then how we can create second validation set? Probably we need to take this portion, and let's say this is val2, validation set 2, okay? And maybe you say, okay, I need maybe three tests, then val3. The point is, as you increase the number of validations in this way, the size of training data set reduce too much, right? And then you end up in another issue. You don't have sufficient data to train your model. This is one of the main challenges in data mining. You don't have sufficient data. Then what do? This is what we're gonna talk about, the technique called cross-validation or k-fold cross-validation. Okay, so you got the idea. It's not good idea to keep reducing the size of your training set, because eventually you may not be able to train your model properly, and your model is going to show overfitting. So what's the point of having assessment while your model performance is bad, right? Due to lack of data. It's not due to some other things, but due to lack of data, having insufficient amount of data. Okay? So what K k-fold cross-validation is all about. It's actually very simple. Just try to focus for 1 or 2 minutes. It's actually quite easy. So there's nothing magic there inside. It's just the concept. So let's say, for the sake of argument, you are interested to evaluate your model 4 times. As we said, having a single validation set, that means you can evaluate 1 time. So let's say you are interested to have 4 evaluation. That means you need 4 validation sets. But we already agreed we cannot keep taking smaller portion from our training data set because we are reducing the training data set. So what do we do in this case? So again, let's assume that k equal 4, meaning we are looking for 4 assessments. So the point is, they come and say, well, instead of keep partitioning your full training data set into smaller portions, no, you stick into the idea that this is your full training data set, okay? And this is your reduced size of training data set, okay? So this is the training set, and this is your validation set. So what do? You come into your full training data set. Since you need 4 assessment, k equal 4, you go and equally partition your full training data set into 4 parts. You see, 4 parts. So let's say P1, part 1, part 2, part 3, and part 4. Okay? Then what do? You take 1 portion out of 4, one of those 4 portions, you select one as validation set. Let's say we have selected P4. Okay, let's say we started by selecting P4. Then you are left with P1, P2, P3. All these are going to be going for training. So you use these 3 portions. So here P1, P2, P3, use for training. Okay, validation is your P4. Okay, so you train your model on P1, P2, P3. You evaluate your model on P4. Then what do? Second round. This time, instead of training the model on P1, P2, P3, you go with P1, P2, and P4. And then this time, P3 is going to be treated for evaluation. Okay, so let's say if we are training decision tree. So here that means I'm going to have decision tree 1. So I'm going to train 4 decision trees. So I'm going to train decision tree 1 on P1, P2, P3, and I use P4 for evaluation. Okay, so that will give me, let's say, score 1, S1, score 1 for evaluation using validation set. Then I train second decision tree. Okay, I train a second decision tree using P1, P2, P4, and this time P3 for assessment, and this will yield S2. So I have score 2 for assessment. Then decision tree 3 is going to be trained using P1, P3, P4, and then P2 is going to be for evaluation, and I will get S3, score 3. And same for the last iteration. So I have decision tree 4, and then here I have P2, P3, and P4, and then P1 for evaluation, and I'm going to get S4. You got the idea? So in this case, how many times I have evaluated my model? 4 different times. And notice each iteration or each time I have unseen data. Why? Because I excluded the validation set, the portion that I have selected, out of the training process. So the model has no idea at all about the validation set. It's considered completely unseen. Then I'm going to have S1, S2, S3, S4. So now I have 4 assessments. This can give me a better idea about the performance of my model. So I can apply, maybe if I need to see the final assessment value out of 4, so I can calculate the mean and standard deviation. These 2 values is going to give me a good idea about the assessment of my model. Okay, clear? So this is in case k equal 4. If k equal 5, same. So in this, if k equal 5, what do you need to do? You partition your full training data set into 5 equal portions. Then you go with the process, same thing. P1, P2, P3, P4 for training, P5 for validation. Iteration 2, P1, P2, P3, P5 for training, P4 for evaluation, and so on and so forth. This is the idea behind k-fold cross-validation. Easy? Let's say after you're done cross-validation and you are happy about your model, what do? You have the final training again back to the full training data set. Same like what we explained earlier, nothing changed. Okay? Anyone need to take screenshot before I remove? Anyways, it's recorded, but if you like take, that's fine. Okay. So already written here, same what just now I have explained. Okay, so split the data into k groups or portions, or we call it folds. Then for each group or each split, okay, what you do, you take one portion for validation, take the remaining for training, fit the model on the training, evaluate the model on validation, retain means keep the validation score. So you need to keep going in this process based on how many k you have set. And then the result of k-fold cross-validation is often given as a mean of the model plus standard deviation, plus standard deviation. So in this case, since we applied cross-validation, so what is the advantage? One of the main advantage, its ability to provide more reliable estimation on the model performance. Okay, so more reliable estimation, and instead of relying on single validation set split. So this time we're going to have many folds. Each fold, as we said, is used for validation set, while the remaining are used for training. By repeating the process with different fold combinations, we obtain more comprehensive evaluation of the model's performance. Okay? So eventually, this is why when you are attending course, you have several assessments. It's good for you, for your own advantage. How to apply? We already seen in practical session. You have cross-val score function. Okay, so this is why we use it, because it has the validation, cross-validation, it applies cross-validation, and CV represent the value for K. CV represents the value of K, the one that just now we explained, K-fold. So CV, so this in this case, CV equals 10, meaning we are going to partition our full training data set into 10 portions, 10 partitions. One is going to be selected for validation and the remaining for training. And we keep repeating this process for 10 times, 10 iterations. So we're going to get 10 scores, S1 until S10. Or the other function, cross-validate, right? We said that there's a new function, there's cross-validate. You can also apply. And there's cross-predict. Remember, just we used it yesterday. Cross-predict, cross-val predict, cross-val predict. So all of them, they are using the concept of cross-validation, k-fold cross-validation. Now, cross-validate and cross-score, they provide you score. Maybe you are calculating for root mean squared error, or maybe accuracy. This one, the one with predict, is going to give you what? The final predicted answer. It's not going to give you any score. So let's say you are doing house price prediction. So it's going to give you the prediction based on the validation set. Okay, so it's going to use the validation set to predict its value. So it's going like to ignore what is the Y label given for validation set and do prediction for you. Why we did this yesterday? Because we wanted to calculate confusion matrix. Because confusion matrix, if you look into the function, requires two things. It doesn't ask you for score. It needs Y label, or we call it true Y. Okay, we call it true Y, and predicted Y. Predicted Y. So predicted Y can be, where's the file? Okay, so predicted Y, you can obtain it by calling the function cross-val predict. Okay, this is why we have cross-val predict. And by the way, if you look to your textbook, the prediction that is given out of this function, we call it clean prediction. Clean prediction. Why? Because this prediction is based on unseen data. So it's clean, not on the training data set, not on the training part of the data set. So they call it also clean prediction. So now using model selection, what do? So you can apply cross-val score, let's say for linear regression or for tree regression. Then you see which one is giving you better score. Then you can select whether you go with linear regression or you go with decision tree.